It will be fast. I can speak a little bit faster, and if you have any questions, then, or if it gets boring, just stop me, and we have enough food and other things to do. So, yes, thanks. And I think you mentioned that there might be some more events to come this Jubilee year.
Yes, we're thinking maybe in November to have an acoustic, a CLIM engineer coming to explain us about the Barrisol CLIM system. So, which is completely different, reaching different clienteles, but still in your presentations you talk about
I talk a little bit to make you aware of it and that you might want to come again in November, but I can start with it now, and it's the first time that I'm doing it like this because it's all modern technique now. But we are just a consultancy which I founded 23 years ago, and we immediately started also to work to Barrisol. Before that I was 5 years in a state-run institute. Maybe you heard about Fraunhofer in Germany. And I was in the institute in southern Germany, and I didn't learn the local language, so I concentrated on Chinese and actually had a chance to go to China for some time. We are now 10 people in the north of Germany, and we do all kinds of acoustics, measuring, consulting, planning. I'm a publicly certified expert, that's how it's called in Germany. That's my local approach towards architects, because I tell them, we can do the planning for you, and if you don't do this, we meet at court afterwards, and then I'm also ready for you. And what brought me to Canada last week was this ISO standardization group, which was held for the first time after COVID now. Usually it's every 1.5 years that ISO meets on a coordinating level, and there is a working group 36 that has been installed 1.5 years ago to coordinate room acoustics in standards, which has been done in other fields of acoustics. Maybe you know about building standards, measuring sound transmission loss and things like this. And there is a working group, by chance it's working group 18 on building acoustics, and there's a quite new working group now on room acoustics. We have 2 projects up to now in this working group, and there might be some other project means different standards are handled in this group, and maybe there are some groups which handle something like 10 standards, but I will not get into this. But that was last week in Montreal, a very nice meeting. We visited the light show at Notre Dame, which was impressive and everything. So that's this, and in Germany we have the Acoustic Society. There's a technical committee which I happen to guide for 3 years now, and I added this for you. This is where our office is. So here you see Munich, Berlin. This is where Barrisol is, next to the border. And my link to Acoustic Plus is that we actually took over the old facilities, the testing labs, when Top Acoustic Plus was sold to another company, and Adrian Eichhorn kept the facilities, and with his son Ansgar I found this company where we are doing now all the tests also for Barrisol. So we have several clients like Barrisol. One is a carpet manufacturer from Denmark. We do some of the testing for Acoustic Plus, so that was my big surprise to see Acoustic Plus here, and okay, that's nice to know.
And I'm from Düsseldorf, which is right in the middle.
You are from Düsseldorf, which I especially added. Next time this will be Düsseldorf, most important city of course in Germany. But here I did my PhD, and you know, in southern Germany it's not only an accent, there are different languages, and it's something different for me. Okay, so now we are welcome to come to Oldenburg from Hamburg. It's 1.5 hours to drive to Oldenburg actually, so that's not very far everything. I'm not going to talk about standards, but we have one standard in Germany. I don't know if you are aware of this. It's one of the few German standards that actually has been translated to English, because many countries don't have a standard like this on acoustic quality in, you could say, in everyday rooms. It's not on concert halls, it's not on opera houses, it's not on churches, it's only on meeting rooms, on classrooms, on rooms of your daily life. So this is maybe somehow special. Some other countries have something like this. In the US you have an ANSI for classroom acoustics, or in Italy, in Poland, they started to do standards like this, but a general standard like this is not, at least to my knowledge, I don't know a country which has something like this. And in this standard you can find, for example, 5 different categories. Rooms for music, which need longer reverberation times, and this is also maybe a little bit complicated on the first view, but it's frequency dependent. The larger the volume of the room, the higher the reverberation should be, because otherwise people don't feel comfortable. If you're in a small room with a lot of reverberation, you don't feel comfortable, but also in a large room, if you think of a church and you have only half a second of reverberation in a church, most people wouldn't like it. I once, the inventor of MP3, Mr. Karl-Heinz Brandenburg, I'm sometimes in exchange with him, and he once told me, yeah, we are all more than a bed as we consider to be, because listening experience and optical experience is very close linked together, so it has to fit in. And so here you could say the more communication you have in a room, the shorter reverberation should be. And one thing, this standard was first published in '68 actually, and we revised it in 2016, because in German classrooms we now have the idea of inclusion, that every child should be in the same room independent of what kind of deficit there is. And so especially for hearing impaired children, we have very short reverberation times. At 200 cubic meter, a classroom should have half a second of reverberation, which is, in the US they go for 0.6 of a second, which is similar, but that was one of the reasons why this standard was revised. And I'm only showing this to you because in some of the projects I show you, I refer to a suggested reverberation time, and that's always according to the German standard. I don't know, do you have Canadian standards like this, telling you lecture hall, 500 people? No.
To my knowledge. Maybe, but...
I think they do.
And especially this green curve has been put in a law on labor protection 5 years ago. So in schools, not many people know, and especially the teachers don't know, but they would have a right to have this in their schools, which could be a big market if somebody would notice. But it's not that important.
I think more, just sorry for interrupting, but
Yep.
we're working on accessibility.
Yeah.
And so for accessibility, anybody who has hard of hearing or deaf, reverberation and all that is very, very important. We're looking at that in all our stores, and I think by 2024, everybody has to comply. So yeah, that is something that, it might not be in the building code, but it's certainly in the association or the accessibility code.
Yeah, and for us it's also not directly in the building code, but indirectly, because there is a code on accessibility, barrier-free accessibility for the handicapped, and this refers to this standard. So some people claim it's an indirect way that you have to stick to this. So whenever it comes to public buildings, people can complain, I can't hear, and then it's not accessible for them. And especially when it comes to children, we have a lot of kids now who have cochlear implants directly after birth, and they really need this kind of acoustic. So, but I will stop with that because it might not be so interesting. We come to micro-perforated sound absorbers, and in the lab they look like this. You see a stretch ceiling, a frame. This is all set in this standard. It's an ISO standard, and this ISO standard is really a little bit old, 20 years. We set up a group to revise it something like 10 years ago. It didn't work out, but last week we made a decision to restart the revision, and I don't know. Now I'm the convener, so you can blame it on me if it doesn't work within the next 3 years. But and the American standard, it's ASTM 423, which is very much equivalent. The US has only a smaller sample size and small differences in it, but in the end you end up with a sound absorption coefficient, which is just what I showed you, the amount of absorbed sound energy related to the incident sound energy. And so it can be between 0 if nothing is absorbed. If it's a so-called hard surface or acoustically hard surface, then everything is reflected, or everything can absorb, and then it is 1. You have hardly any materials that absorb all the frequencies that are involved, but most of the materials, like a carpet, some of them only absorb high frequencies, others are for low frequencies, and what you try to achieve is always quite a homogeneous sound absorption, but that's what you will see later. And these sound absorbers are somehow different than traditional materials. You don't see any fibers. You can add it to that, but it relies on a different principle, and the principle is not very new, I have to admit, because it comes from China. In the 1960s, there was this Chinese professor, Ma, that's a third tone if you're interested in Mandarin, and first name Da Yu, and he had some work to do at that time because they were looking for special materials in test rocket stands. And then he had this idea of a micro-perforated sound absorber. I will show you some of these projects. In 1993 there was a big problem in the German parliament, Bundestag, and that was fixed with something like this, similar. And I think your parliament got the same treatment.
Yes, in Ottawa.
Yeah.
Coming January.
So, and the Austrian parliament is presently under revision, so it seems to be something for parliaments to have glass roofs, and you always need microsorber then, so that's the way to handle parliaments. But then in 2001, that was also incorporated into stretch ceiling, very soft materials that you can see here, that you have probably touched. And there are several other applications, and one of the latest is this heating, cooling, light, sound in one ceiling. This is what you can see here. So I will just give you a very quick review on Professor Ma. So that was the day of his defense of his PhD thesis in Harvard in 1940. So some time ago. And he did it on the same day at Harvard University with this young gentleman. You know him? Maybe you heard the name? Leo Baranek. He founded Acoustics Consultants and others, and he was an acoustician. Then nearly every 20 years in his life he changed his mind. Then he founded something which is called now ABC News, a radio station. He was one of the inventors of the ARPANET, which is now called the Internet, and he was very active till he was nearly 100. I met him in Montreal 10 years ago. He was here at an age of 97. He was honored at the meeting of the Acoustic Society of America in Canada, joined with the Canadian Acoustic Society. He was honored for his membership in the Acoustic Society of 75 years. That doesn't happen very often, but that's Leo Baranek. He died a few years ago when he was 103. He got 97, and it seems to be that acoustics helps to get old. Yeah. I keep inviting friends and people to a Wednesday when I will be 100. It's a Wednesday. So I was lucky to go to Qingdao, which is a former German colony, and I stayed 4 months in Beijing. That was maybe you can read it, the annual meeting of the Acoustic Society in May '99. Maybe you can spot me. This is Professor Ma, the most important Chinese acoustician at that time. So he was sitting in the middle. I'm not in the middle. I'm here. So different haircut. But there are many people, Tianjin, for example, who is now the president of the Acoustic Society in America, and many others. That was me, also with a different haircut. But he was very active at that time, around 80 years old or something. So it's really very interesting time. And if you need further reading on the scientific side of it, we published a paper. It's interesting. I don't know what's written in there, but they took my name on it, so it's. But his idea, and that's described in the paper, is how you can, from a purely geometrical setup, you have a sheet or a plate of a certain thickness, which is for Barrisol, of course, a thin sheet, and then you can calculate the amount and diameter of the holes you need. And the backing distance, the resonator, is important. And from these 4 parameters, you really can calculate the acoustic properties. It's a straightforward physical theory, has to do with sound propagation in narrow tubes, and it's only the geometry. If you have some micro-perforated wood, I think here from Acoustic Plus, it's the same principle. That's micro-perforated acrylic polycarbonate, and you can do it in any material. So that's the basic idea. It's a matter of friction in each single pore that is used, and Professor Ma gave me some of the formula. It might be interesting for you to see. And it looks, maybe if you see it, it looks a little complicated, because here you have complex Bessel functions which you never have heard of, probably. So that's why he gave an approximation for this. Even in the year 1960 he did all this, and this is more for the acoustic consultants, or if you want to read through it. It's really just you add up impedances of a layered systems, and you end up with the absorption coefficient for statistical incidence. So it's really straightforward. You need the theory, and then that's fine. I will skip this a little bit. And if you do a calculation according to this theory and you produce a material like this, then it's quite nice what you can predict, and very nearly exactly what you measure afterwards, which is, from my point of view, quite interesting still, because you have, of course, you have other sound absorbers like fibers and rock wool and whatever. You can also predict, but you are not that flexible by changing different things. And what I said is that these 4 parameters, and you have a color card somewhere? Yes. Have you seen this color card? It's an old version. It's 22. But no, the new one will be 2 parts. I heard that. Because, you know, when I started to work for Barrisol, it was like, now we have the color card.
We've been working for like 20 years.
And now my arms are not really enough. But here we have basically the 4 micro-perforations.
Right here.
They are in here. And if you go to it, yeah, you can see the A15 has the smallest diameter and needs the most holes. Then it's always a matter of number of holes or distance between the holes. And the A40, that has actually been there before Barrisol knew that it was acoustic, but it's still there. It's not that absorptive, but it also works. And then according to the diameter, you need different distances, which gives you the number of holes per square meter. So we have between 500,000 down to 50,000, and the thickness of the sheet, when it's stretched, it doesn't really matter if it's stretched or not, but it's around 180 microns. And then you can play around with the backing cavity to tune it to whatever you need. So I will show you a little bit. And the first project where this actually has been done, to my knowledge, was the House of Parliament, Bundestag in Bonn. At that time they built a cylindrical hall out of glass, which is not a good idea sometimes. You get focusing points, and even the sound system crashed during the first meeting. Maybe you heard that story. It was really an issue, because it was not cheap, that building. But and then they put up some sound absorbers here and some sound reflectors. So the sound was reflected out of the focusing points into the members of parliament who were sitting in the back. And these members of parliament who are sitting in the back, I don't know how they are in Canada, but in Germany they are there, but they have not really something to say. They are just sitting there. And we invented to give them a new function. They acted as sound absorbers of the reflected sound. So, and of course we would absorb some sound here. And when you get closer to this, it was a 3 or 4 millimeter plexiglass, acrylic glass, and this was done by lasers. So you can still buy this, but cost-wise it's something like 500 euro a square meter now. So I think that's not for anybody. And it was built like this so that it could be opened, because they thought the dust might fall into it after a while and you have to get it out. But it's really not very, it's not really very realistic that any dust will get through a tiny little hole of 0.5 millimeter and then directly hit it and get into it. So they never opened it over the last 30 years. That was acrylic glass, and then the first project with actually this product, which is now owned also by Barrisol, the micro-sorber, is it's this one. That was a.
It's not stretching. This is like more like.
It's a polycarbonate, so it's resistive to UV light. You can have it in front of facades of glass, and at that time we had also measured data. We compared it for different distances. That's a double layer setup, and installing a double layer setup brought down the reverberation time from 3 seconds to less than 1.5. I don't know if you have this. We have a German swimming pool guideline. We have guidelines for everything, you know. We have a swimming pool guideline. We have a tunnel for tunnels guideline, and it's always something like this. And we really achieved, well, 2 third Bach octave bands didn't work, but the rest was fine. So the client was happy, and that was decrease in sound power level, which was also agreed was of 5 dB. Measured with a reference sound source, not with the people, but with a reference sound source. You can have other installations. Now that's a more recent installation. It's under thermally activated concrete, and you can, of course, you can say how much heat should be radiated through it. We have some radiation values for this, and then the thermobability physics people can say how much you can cover, and that's also a way to work. One of the other projects in Berlin, which became quite famous within Germany, was this Schlüterhof. It was called. It's a state banquet hall, also a museum, and they had excessive reverberation of something like, I don't know, nearly 20 seconds, which was lowered. And one later project from our city is a shopping mall where people really complained and shops went away because of, well, nobody really felt comfortable. One of the reasons was acoustics. If you go to a shopping mall, open your ears, and sometimes you wouldn't like to stay there for a long time. So we did a little 3D model and cut A. So, and then we measured, we put in the sample, measured afterwards, and then it fits quite well. And the owner decided only to do this part. Now he is thinking about doing this part as well, because you get a clear difference between the two parts. And that's I wanted to show you, because this is how it's installed. What you can see here, still the same spring and ring system, and this was done during one Saturday morning, just to give you an idea. So that's how it looks like. Here you can most of the fields are covered, but these triangles, for example, are not covered. But of course, if you know it, you can see a difference, but it's actually not too bad. So that's another project. That's also a swimming pool. I don't know exactly where it is, but that's a canteen. Here you see the installation. Looks a little bit technical, of course, but that's the way you do it. Or here a swimming pool again. They didn't want to put it under the wood, but they put it around at the glass. So these are all the possible things to do. And of course, you know how this is this non-flexible sheet, polycarbonate, and then it was introduced into this flexible membrane, which is, you have to say this, it's PVC based, but it's a modified PVC, which also is fire rated and everything. And this harpoon is always glued on the sheet in the factory in France and then sent around the world. How long does it take to come to Canada?
A week and a half.
A week and a half, yeah. So
yes.
If there are no public holidays.
Exactly, because we're talking like in France, like in May, they have like maybe five days of holidays.
Yeah.
So we have to plan ahead for orders, because everything just gets mixed up. So
today is Liberation Day, the day the French are happy
so you don't celebrate that, I guess.
We don't celebrate that in Germany, but it's even one more day in France than in Germany. And that's how it's installed, and can also be reinstalled. And the first project we did was in Hamburg, not the main church room, but it was a small room in the church where they held up lectures, but also music rehearsals with choirs, with little orchestras, and people complained about bad acoustics. And here you see the situation before, and here is the situation afterwards. This support was important. because there was a picture. And if you see this, here we see this little black shadow, and reverberation was brought down. We had actually 1, 2, 3 of these arches covered by Barrisol, which showed reverberation time from 3 seconds to a little bit lower than 2 seconds. That would have been the suggested range for lectures and speech. The musicians were happy afterwards, but not the priests. They said, it's still not easy to talk, to have discussions and things like this, but for the musicians this room was fine. And this is how it looks afterwards. Here you see the picture on the support, and here you see the Barrisol stretched. This is what we measured before, this is what we measured afterwards, and that was our theoretical prediction. So again, for this we didn't even do a 3D model. It worked, and if you look at the details, here you can see the 250,000 holes at that time, and it's open due to humidity reasons to get some convections out of these old and ancient walls, but yeah, that's how this was done. You can use it in pools, you can use it at home, and now we come a little bit to the data. That's the sound absorption coefficient you see for a 10 centimeter A30 setup, which for example was used in the swimming pool. You don't have any problems with humidity because it's only the sheet and air, but this gives you something like NRC of 0.55. NRC is a kind of average value. You probably also do your designs in octave bands or something, which
we do third octave.
You do third octaves, and third octaves is actually what you get out of the testing lab, and then all these is deduced from that. So you can have totally different curves to the same NRC. So NRC is not really, has no big meaning, but in Europe we use a lot of this alpha W, which is most of the time very similar to NRC. There once has been the idea of harmonizing ISO and ASTM, but that's politics and didn't happen. So if you have just a classical sheet without a micro-perforation, you see you have hardly any sound absorption or frequency bands. But when it comes to the micro-perforation, 10 centimeters, so speech 500, 1000 hertz, then you get more than 60% for this setup. And that's maybe the comparison without micro-perforation, with micro-perforation, which gives you quite an amount of sound absorption. If it's possible for the room, you can also add some porous material behind it. Here again we have the 10 centimeters with 4 centimeter of acoustic fiber, and we found from different measurements it's not really important what kind of fiber you have. It can be rock wool or glass wool or even a kind of foam or whatever, or polyester fleece. It's only important because that it's there, that it has a certain thickness, and then it will shift the absorption towards lower frequencies. So the NRC goes up from 0.55 to 0.85. And if you have it unperforated or perforated with filling, it's always only 10 centimeters. It's the same optical impression, but totally different acoustic meanings. And this is probably something, I don't know how your feeling is, but my feeling is that there are still consultants who will not believe that it works like this, but I can only say it works. But oh, you missed something I have to show you. The company who installed in Oldenburg is Niederstein from Cologne. So yeah, and for example, one thing is when you open the sides, you weaken the resonance cavity behind the sheet, and then you see it loses some of its effective absorption coefficient. So we have also measurements for setups like this, or setups freely suspended in the air. I will not show you all the, I don't know, 1200, 1500 measurements we did in the last 20 years, but most of them came from projects where some designer said, I want to use it like this, and then we said, okay, we can do it like this, and we have done it in so many projects from India and South America and everywhere, and so this is why we have so many measurements for different setups. One project came actually from New York for light design, and that's how it's ended. You have one sheet with a micro-perforation, and a closed sheet for the light diffusion, and then everything that might be there, like a dying fly or some dust or dirt, will stay here, and you cannot see a spot or anything in the lighting ceiling. So the test result, for example, for a double layer setup, 2 layers of micro-perforation gives you also 0.55 NRC, but with a different curve in a way. And sometimes light designers don't like this, because for certain angles you can see the spots getting through the sheet, even with double layers. And what you can do then, of course you could add something behind, but that doesn't help. But then you have the first sheet unperforated and the second sheet perforated. And this gives you also very homogeneous lighting and also absorption, not as much as before, but of course you could also add something behind, and you can do this also with this one, unperforated, perforated sheet and something behind, and then you are again at 0.5. So most of the time in many rooms you don't need any absorption for 2000, 4000 hertz. This is where the carpet or anything in the room acts as absorber. If you look at speech, female voices in this area, male voices here, that's probably most important, and this is what you can reach by a setup like this. And it's a light ceiling with sound absorption in it. That's a picture from an installation. You see it's heated up around 30-40 degrees. I never installed.
48?
48.
No, it's between like 38 to 42, 45 max.
Yeah, it depends maybe also a little bit on the size of the sheet and everything like this. So maybe I should ask Edwin that I can join him one time to Egypt to install ceilings or something like that. And then it looks like this in the end, or that's up to you what kind of shape you want, whatever. That's always possible. For the acoustics, if you have a shape like this, I would suggest to take the average. So if it's between 10 and 40, just take the 30 value for it, because we didn't test everything. I think we tested it sometime when we had it curved in a way like this, so that from 10 to 40, and then that was nearly the average value that you got from that. So, or other installations like this one or this one, a playground. These are some office meeting rooms, and here, or you know what you can also see with the lighting behind it, different colors, printing. I think you can see it live here as well. Well, this one is from, I think, from Dubai, if people like it. Next time you come to Cologne, we can go here to Cologne Löwenich. It's a little pub. If you look here, that was a gypsum board ceiling. People complained, too noisy, I don't drink a second beer, I leave. Now they don't leave, they have a second and a third beer, because acoustics has improved by adding a 5 centimeter acoustic ceiling. If you watch out for this space above this outlet, you will see that not only the light is switched on, but also the sheet is installed with some fiber behind it. And this I'm showing to you because not it's only a German pub, but it decreased reverberation from a little bit more than 1 second to less than 0.6 of a second. Again, it's about 50% less reverberation, but it also improves speech intelligibility very much, so people don't raise their voice. And maybe you have heard about this Lombard effect, it's called, or you can call it coffee house effect. You decrease by 50% absorption, gives you theoretical a decrease of 3 dB, but finally people don't have to talk that loud, so it's more than 3 dB in the end, so it's probably 6 dB. You know that from every good party ends like a good party. I read some papers about it. It's when it's going up 3 dB per hour. So you know this effect. You are talking, music gets loud, not as loud. Then you turn on the music, and then at 12 o'clock it's everybody shouting. That's another acoustic ceiling with printing, with spots in it, with backlighting, And it's my favorite story to tell you that it got its first Michelin star when the Acoustics was fixed in this room. So that's a restaurant. You know that.
Yes, I tried the desserts.
Yeah, but you probably didn't sit here because that's.
I work by the windows.
Yeah, because it's much better to sit under an absorptive ceiling.
Oh, yeah.
Here we still have the gypsum board and you get strong reflections from the top, and this is what people don't like very much. And if you're sitting at this round table, it's a nice table, but it's better to sit here acoustically. Food is probably the same everywhere, but some more details from that room. Il Cortile in Mulhouse, and small room. Larger room is this one in Oslo. Snohetta Architects did it, and I went there actually with Jean-Marc to see the architects, because in this project we had 3 acoustic consultants, one for the main theaters, one for the rehearsal rooms, and local Norwegian consultants for the other public spaces, and one of these spaces was the foyer. And here you see outside it gets out of the harbor, out of the Baltic Sea, all white marble, and the architects wanted to have it the same impression optically from the inside, and so that's why they installed 4,000 square meters of Barrisol. You cannot stretch 4,000 square meters in one piece. It will start to sag, so it's always divided into 50 square meters. This is what Barrisol says, sagging not more than 50 square meters. When it's rectangular or when it's a square or something like this. If you have a very long corridor, of course, you could have it 100 meters long in one piece, something like this. That's another public room now, a swimming pool, aquatic center. That was done by Zaha Hadid Architects, and that is not fake concrete. This is real concrete. But the acoustics comes from the lighting again. So that's also a way to handle it. Of course, you could have had printed, I think you have somewhere printed concrete here, so that's also something you could do, but here it's slightly different. Or maybe you heard about this company selling cell phones and also like nice designs. So in several shops around the world, Barrisol was installed with the lighting and also the other acoustic ceilings. And they had very special requirements on the light color and everything, so that's always an issue. Again, small rooms, big rooms. That's two classrooms in a primary school in Alsace near the factory. The architect wanted clouds, so you can do clouds. Over there you have a cloud clean, which also allows you now to combine the climatization with the acoustics and everything. So that was printed Arculus clouds, or that one was a training center for the Qatar football championship last year. So that is all A15, what you can see here. So sometimes clients have special requirements. I don't know how you like these clients. We are selling sound absorbers. Yes, but we want a ceiling that does not absorb sound. Huh? What do you want? That was this project in Portugal, where the local Portuguese acoustic consultant has set all the acoustics in the ceiling above, and the interior designer wanted a special pattern in a acoustically transparent ceiling. So that's what they got. We tested it, that it's really giving no absorption and no transmission loss, and then it was installed. We did the final proving measurements for the general contractor, and yeah, that it's how it looks like. So that's a non-acoustic ceiling, but also stretched pattern. Okay, you're still awake? So the last thing, and that's probably a better way if Damien explains this in November, or whenever he will be able to come, but he will tell you the latest invention, which is a modified profile with holes in it, and then you can use the backing cavity to get air through it, and that's the idea of it. It can be going in to the room or getting out of the room. Over there you can see a big poster where it's printed on it, and As far as I know, you have 3 different types of this rail. So with the type of the rail, you adapt it to the room size you have and how many airflow you want. And each room is done in a single calculation. Then you close it to get the air out. But what you finally have, you have a system like this where you can get air in. You don't need any piping or whatever. You just get the air into the cavity. Then it's pressurized a little bit, blown out, and then you get a kind of air movement by convection. It's a kind of forced convection actually, because it's cooling down or heating up the upper wall. And Marek thinks I've seen it the first time here. The blue is where it gets out, and now you have to look for the red where it gets out of the room. So here it gets in, and over there is the red. And it's a very nice idea to do it with colors. And then you get a forced convection. And as this one is maybe cooler or warmer than the rest of the room, you also get some radiation from the ceiling. And people appreciate radiation on their head because this makes up the perception of thermal happiness. And so this is something like 40-50% radiation, and the rest is energy exchanged by convection. And come again in November. Damien, will you explain all the details, how this can be achieved? We have very slow flow velocities. You cannot feel it at all. Go to this room. It's really always interesting and fascinating. And one of the first rooms was the showroom near in Germany. It's an acoustic ceiling and with lighting and with cooling in summer and heating in winter. Here we have also artoliths, printed frames and everything like this. And another room near the factory, which you might see when you visit the factory, is this room in St. Louis. Also 3 functions in this ceiling, and here I can show you the measurement. Very short reverberation times, but for video conferences or something you want it short because you don't want to have any disturbance from the room. So that's nearly all I can tell you. One more thing which I personally like very much is something I will show you here. That's also a room with a lot of glass. You have these. Oh, there's one as well, these mantas. And then we have the printed here. And if you turn around in this room, you will have this one. You have a mirror, and it's 6 meters wide. And people, when they come to this restaurant, it's a 1-star restaurant in Strasbourg. They come to this room and ask sometimes, how do you get this mirror into this room? And then you can tell them it's not a mirror, it's a micro-perforated sheet with printing on it. And so it's a sound absorptive mirror, which is also a nice thing. And usually I only go to restaurants where I've done a measurement before, but sometimes or very often I do measurements in rooms where I don't have a dinner afterwards, and this is one of these rooms. So here we see that's this room, that's the reverberation time. I don't know how your feeling would be like this. 1-star restaurant in a reverberation time between 0.6, 0.7 should be fine.
Not good.
Not good? Oh.
It's okay, it's okay.
It depends on the wine, yes. Okay, but
How much?
how much wine? Yes, after a while every room gets good, but here even before the first wine. Okay. Okay, now I'm finished. Just to conclude a little bit, it's really an old idea, but it offers many new possibilities. It gives you this idea of transparent sound absorption, so you are not, and you can combine it with anything else. This is what I think is really maybe the task for designers, not to think in acoustics and lighting, but think it all together in one way, and you have all the new possibilities. So it's up to you to find solutions or propose solutions to people who don't know much about it. But there are still a few people around, I fear. Okay, thanks a lot.
Thank you.
Thank you.
What I want to say is I've seen this twice now, this presentation, but the thing that I find I take away the most is that a lot of acoustic products that are on the market, you get what it does what you buy, and that's it. With Barrisol, it works in all different scenarios. It's just a matter of finding out what you're trying to achieve, and then by either having more air gap or adding insulation, we can get to that. So we just need to know what you're trying to achieve, and as long as the cavity is that way, it can be accomplished. And there's tests to
Yeah, and it's what I see from many countries is that it's not understood, that it's up to you to define what you want,
Yes.
and then it can be achieved.
Yes.
And that's sometimes even the problem of Barrisol, that it's hard to explain, that it's so flexible and you can adopt it also acoustically. And
yeah.
if you go to Knauf or Ecophone or whatever company, Rockwool, you get an acoustic ceiling that has something NRC of 0.8 or something, and then you get a ceiling that has an NRC of 0.8. And it looks tiles, and it's always the same. You can.
Yeah.
And I think it's also, I mean, when I remember acoustic ceilings, how do you do that? Floating panels, right? Baffles, so it was another addition or another layer to the ceiling.
Yes.
So you had to have a fire rated ceiling, then you had to suspend panels, and so it was double the cost, right?
Yeah,
Whereas
but
if a designer incorporates this right from the get-go, and that's sometimes the challenge, is that, like, if I was going back into, you know, if we have designers here, they go back and they design with this in mind, and the fact that you can get this clean ceiling without those ugly diffusers and, you know, air vents, and it's just so beautiful to do around the perimeter. So you're saving on one, you know, equipment in some sense, and you're getting this beautiful sort of ceiling,
Yeah.
right? That's part of the design. Like,
Yeah.
it has to be right at the get-go. Like, for us, we've been dealing with a lot of acoustic issues after the store's built, which was, you know, you can't do much, right? I mean, it is what it is. You've got mall traffic, and in the store, you've got that conversation going between, you know, customers. So if you know about something like this, but then, you know, budget's always limiting, right? So there's always that, where do we cut? But if you're doing, you know, now we're doing cloud ceilings in our new concept, which
Yeah.
is open plenum, which helps cut down on, you know, the acoustics, or improves the acoustic in the store. We're spending money on that. Yorkdale, we've got the Barrisol in Yorkdale. I wish we had done some testing before and after, you know, or even taking you know, at the Yorkdale store and going to something similar,
Yeah.
and comparing what the DB is, just to see,
Yeah.
you know, if there's a difference. But Yorkdale is, you know, a perfect example of, like, similar to the
Yeah,
Apple store.
if you don't do it in advance, that's, for example, a friend of mine, or it's actually my doctor, he had a big issue in his office, people really complaining, and then he was looking at different possibilities, and I also mentioned Barrisol.
Yeah.
And then he was just thinking, okay, they can install it on a Saturday when everything is closed, and then the price was no matter for him. So it was probably a little bit more expensive than any other thing, but it, for gypsum board, in Germany or in Europe, we have, I don't think you have this very much, perforated gypsum.
Yes, we do.
Yes.
Yeah, you have that? Yeah. But that always takes a few days to get installed, and closing down something.
Messy.
Yeah,
Well, and
everything.
you can only paint it how many times, because every time you roll over it, the
You
holes
reduce-
get
reduce,
smaller
yes.
and smaller, right? Yeah.
Yeah, tiles, I think we have to ask Mario about tiles that have been painted or whatever, or even the fibers from the tiles is an issue. So
Well, thank you.
thanks a lot.
Thank you so much.